Ultimately, the higher throughput blockchains, I think, enable more expressiveness. Part of that is having the larger blocks and being able to propagate more data. Solana, for example, has 400 millisecond block times. It's, as you pointed out, with the centralized exchanges, you want to get the block times down to as low as like physics allow. The circumference of the Earth with speed of light is 133 milliseconds. So you can get latency down to that point. Maybe you can get 200 millisecond block times, which is definitely not as low as you would be able to get at, for example, a New York Stock Exchange. There are a lot of things that I think ultimately open up, but moving and kind of subsuming the financial system, I think, is one of the more interesting things.
Hello, and welcome back to another episode of Mind with CoinFund, a weekly podcast about the most interesting things in crypto that no one is talking about. My name is Jake Brukhman. I'm the CEO and managing partner at CoinFund, and I'm sitting here with my partner and CoinFund's head of venture investments, David Pakman. Hey, David, what's going on?
Hey, Jake. Good to see you. I'm a little sad that summer appears to be in its final chapter, but there's a lot of cool stuff that seems to be queued up for the fall in crypto. Talked to a lot of teams this summer that have things launching in the fall. So I think we're going to have an interesting next few months. What about you?
I cannot wait for election clarity. I think clarity is good. I think founders want to know where they stand with the government. I think they want responsible regulation and legislation and an environment where they're free to build innovative tech products. So I think the election will go a long way in deciding that. And of course, it's all the rage on prediction markets these days as well. So let's see where we get to. What about you, David? What are you predicting or thinking as the fall leaves fall around us or start to?
Well, it's interesting you mentioned prediction markets. Like, sort of my favorite thing to do is to not predict, but to look at evidence and draw some conclusions from little breadcrumbs and dots and things like that. And so I think there's more than almost $700 million have been wagered on the election on an on-chain prediction market, Polymarket, which is an enormous amount of money and hundreds of thousands of participants. We have things like Telegram and the Ton blockchain and the Hamster Combat and some of the other games built on top of Ton that are achieving like crazy numbers, tens of millions of users on chain in a short amount of time. Not many people in the US talking about it because it's ring fenced away from the US because of that lack of regulatory clarity that you talked about. So I think that's some extraordinarily interesting big numbers. I'm looking at some of the DeFi fee generation by the leading DeFi protocols. They're at all-time highs. So like a lot of the functionality around borrow lend and yield management that we've been investing in for a while and talking about is really reaching a level of maturity. So I don't know. I'm pretty psyched about what's getting queued up. I've also met a bunch of teams that are launching in the fall, as I mentioned, and many of them are going out with interesting consumer apps. So I'm looking for evidence. I'm looking for examples that we can continue to point to show that we're marching towards the mainstream.
Amazing. Well, I'm excited to see what happens as well. But for now, I'm particularly excited to introduce the next guest on our show. Fun fact, I actually went on his podcast a few weeks ago to talk about started CoinFund, had a conversation about decentralized AI and also crypto life in Miami, because Logan and I both live in Miami. I've known him for about a year and a half. I'm an LP in his fund. And I'm really excited to have him on because I think Logan has a super interesting view on blockchain scalability and the high throughput debate. He is the co-founder and managing partner of Frictionless Capital, a Web3 investment firm that recently announced its first fund in July. And so please welcome Logan Jastremski to the show. Welcome, Logan.
That was a beautiful intro, Jake. I need to have you come on my podcast and do intros every time because you're much more eloquent than I. But appreciate the introduction, David. Nice to reconnect as well. Looking forward to the conversation.
Awesome. I think what we always do on this show, and I think we should just get it out of the way, is we always ask, what are people not talking about that they should be talking about? So let's get Logan's view on that right up front.
Some alpha. I think for us, we focus a lot on the infrastructure stack just so we can move up the stack to applications. I think at Frictionless, we're very focused on what blockchains are uniquely capable of doing well, which I think is coordination. And the subset of applications that I think fit that description are really around the decentralized physical infrastructure networks. I don't know if it's like alpha, so to speak. I still think it's fairly early in terms of these coordination networks, how they ultimately scale, but that is one thing that I'm uniquely excited about. And then maybe one extra tidbit, part of the conversation around blockchains has really been around trading, more recently meme coins. That has continued to move towards MEV. What are the implications of MEV and the different designs that either are good or bad for MEV, which I do think is an interesting topic. But I think one thing that people are not talking about is the opposite side of that coin, which is order flows. So I think of MEV as like the taker side of the liquidity of an order book, and order flows are on the maker side. And to actually have a sustainable economy on chain, you both need takers to generally be profitable over time. Otherwise, they're not going to trade, but you also need market makers to be profitable over time. And I think that conversation is much less widely spoken about, is how do you make market makers profitable over the long term, which I think is ultimately going to derive from order flows. One area or a couple of areas of focus that we've been spending a lot of time on is particularly trading within and focusing on the subset of order flows, and then also moving up the stack to applications focusing on coordination networks within DeFi.
Awesome. Maybe we should also start by asking you a little bit about your background and how you got to be the manager of Frictionless today.
If you ask myself if I would be in this position a couple of years ago, I would say no. I think my superpower has just been going in a certain direction and making it happen. I ultimately started my career out in the Bay. I was obsessed with product, and I thought product was probably the coolest job that you could have in technology, at the intersection of actually building a product versus having some ability to influence that in a certain direction. And so figured out how to get a product job out in Silicon Valley, ultimately transpiled that into being able to spearhead Tesla's supercharging network on the digital side, leading all the back of the house operations. And that was a very interesting experiment. I call Tesla kind of like the Great Wall of China, so to speak. Many people will go, most of you will die, but the wall will get built. And it was an interesting place to work just because you move so quickly. There was a lot of mistakes that ultimately Tesla made, but I think that pace of iteration ultimately pushed you and everybody fairly hard to build exceptional things. And I think my biggest takeaway there was not only moving quickly, but actually thinking from like the first principles. And a lot of people say that they do that, but it's very hard to actually understand like where do the physics of these things actually manifest themselves, because that is the law and everything else is recommendation. And so spent 1 year at Expedia Group, starting out my career, 1 year at Tesla, and then got really interested in blockchains really in 2017. And at that point in time, Ethereum was predominantly just used for ICOs. Thought I was a genius for a little bit towards the tail end of 2017, probably as most people did, but quickly got humbled throughout 2018. But I was still fascinated with the concept of kind of these permissionless DeFi Legos and composability. So I stuck with it. And ultimately, throughout 2018 and 2019, got really excited about the applications and the progress, but really got interested again once DeFi summer was happening, and started playing around with DeFi contracts. There was yield farming, DeFi tokens on food tokens going around. It was pretty crazy, but it got frustrating to use because ultimately gas fees just got prohibitively expensive. And I paid $1,000 for a Uniswap transfer, and I was very frustrated by that fact. So I started to apply the Tesla methodologies of understanding, again, what is the physics of these things and why are they having such a difficult time scaling? And that ultimately led me to start my podcast, which was, even before I started a fund. And the podcast's goal was just to talk with smart people because I didn't get invited to any parties. I wanted to get in the correct rooms and say hello to people, but I felt like an outsider. Fast forwarding to today, ultimately, that podcast has led me into starting a fund. And the fund's unique thesis was really around being more opinionated on the infrastructure stack so that we could go to applications and those applications can actually be used at mass scale. And it's been an interesting journey. Definitely didn't think I was going to end up here, but one thing led to another. And I think being opinionated online perhaps helps with that a bit.
Let me go another turn of the screw there. So as I understand the thesis that you've been embarking on, Frictionless has a lot to do with investing in more modern versions of infrastructure that will create high throughput, highly scalable blockchains. First, it makes some logical sense that like the first version of blockchains as proposed are not going to be the final ones, right? That there'll be maybe some disruptive innovation itself and how we architect them so that they can scale better and handle higher throughput and TPS and things like that. But there's also needs to be an assumption that if you build it, they will come, right? That like by unlocking higher throughput, more scalability, that enables applications to be built on blockchains that otherwise couldn't be today. You talked about DPIN. I'm curious to hear some examples of DPIN networks that require 10x, 100x more scalable blockchains than we have now. But you don't have to answer that question first. Just what's the world of applications that you think appear as more modern, highly scalable blockchains become de rigueur?
It's a good question. I got to ask this recently, and it's a little bit hard. I think it was Chris Dixon saying something along the lines of the first iterations are schizomorphic, and the fact that they're not actually representative of the technology and what you can do. It's a copy of what you could do in the past, and then you move over. And I think with high throughput blockchains, we've seen that same route. In my opinion, Solana was probably the first high throughput blockchain. Now there's a couple others. And a lot of the first iterations of application was like, hey, let's do the Uniswap equivalent on Solana. Let's do the Aave equivalent on Solana. And those are fine. But to your point, David, they haven't really made unique strides. And I think it's taken now, I would say, 3 years of Solana really starting to enter the mainstream. Obviously, they've had some issues with downtime, working out the bugs, the kinks, for builders to now start to experiment with that. And I would say that has really only started to manifest itself in the last 12 months, so to speak. The kind of cliche one that I think everybody points to, which I also think is like directionally true, is order books. When you have 12 transactions per second, it's fairly hard to update bids and ask on a blockchain. And once you go from low throughput to higher throughput that enables more transactions per second, you can do more interesting applications like order books. But I think that in my mind is maybe like the 0 to 1. But I think the maybe underrated piece of this is, in my mind, one of the unique benefits of once you actually start to scale is you can have more applications within a single ecosystem. And that, I think, is really one of the underappreciated parts about blockchains, is that when you join or use a blockchain network, all the application engineers building on that blockchain kind of opt in to a same set of standards. And that standard is really important because the more that you fragment those different standards, the less you can agree upon things. I think that's what gets us back in the TradFi world. And so part of it is, yes, like there are some 0 to 1 applications like order books. Admittedly, there's less than I would like to see. But I think as engineers start to continue to experiment with high throughput, what's possible, applications will continue to emerge. And then the other part of that is creating a blockchain that's scalable to fit multiple hundreds of thousands of applications within it, where they opt into that shared standards, and that shared standard kind of creates that compounding effect. What got me so excited about DeFi Summer, where everybody was on a single shard, which was Ethereum.
I'd love to jump in here in the interest of scientific clarity and ask you, Logan, like, how do you define a high throughput blockchain. And what unit is that? Is it like number of people who could be on it? And what are the main ones? You called out Solana, but I think there's a few others that
there's definitely a couple more. I look at it from an engineering point of view. Most of the blockchains, as their name indicates, are a chain of blocks. In those blocks, you have a finite amount of data, which can fit a certain amount of transactions within a block. I believe the Ethereum blocks are in between 80 kilobytes and 100 kilobytes, which is relatively small. With 4844, they added blobs. But moral of the story is, within those blocks, there's only a finite amount of data. Whether you fit 10 transactions or 100 transactions, that's fine. The only way, though, for you to increase the overall throughput of the network is either to increase the amount of data that the blocks can handle, or increase the velocity of blocks. Or maybe option number 3 is use those block space more efficiently with data compression, which I view as layer 2s. So how I think of this is, today, the blockchains that kind of kicked off the industry were really only measured in kilobytes. There's 1,000 kilobytes and 1 megabyte. There's 1,000 megabytes and 1 gigabyte, 1,000 gigabytes and 1 terabyte. So each one of these jumps are 1,000x. Today, the early iterations of blockchains are doing less throughput than dial-up modems in the past, which was 56 kilobytes. Once the internet went from dial-up modems to low broadband, that's where you started to have the YouTube type applications of the world, where you could do a little bit more expressive and make a little bit more content rich type applications. And I think today we've gone to that jump, which in my mind is now Solana, Celestia, Sui, Aptos, Say, Monad are kind of broadly in that bucket. And then in the future, we'll go from megabytes to another 1,000x, which is gigabytes of throughput, and then beyond. I think, to answer your question, it's probably, I want blockchains to be faster than dial-up modems. If they can do low broadband type speeds, I'll be happy. But eventually I want to see gigabytes.
Nice. Very good. And maybe, like, just to jump in here one more time, like when I think about blockchain scalability, there's this set of like almost dual views that exist in the market, right? And maybe one way to explain them is like horizontal versus vertical scaling, right? So like the horizontal scaling people say, if you want more throughput, like just add one more L2 or add one more blockchain, or, in each individual one, it could be like slow, but if you're operating them in parallel, you're increasing that metric that you just talked about, Logan. And the vertical scaling people say, you know what, the bytes per second or transactions per second, higher and higher and higher on a single blockchain. And maybe you do that by increasing the hardware requirements of the nodes and so forth. So there's these two views. Do you agree with my taxonomy here? Like, does one make more sense to you than the other? Are they going to coexist?
And Jake, isn't there also a third where you break nodes into multiple functions so that each node is burdened with less of a job, right? By breaking off security.
Absolutely, David. We've seen that in Flow. We've seen that in probably like a few different blockchains. But so it's a good question for Logan.
I think the early assumption of the cypherpunks of the industry really wanted Bitcoin to be run on as low as hardware requirements as possible, because they wanted it to be as decentralized as possible. And Ethereum came along and say, hey, we can make Bitcoin more expressive, Turing complete. We can build applications on top of it. But they took a lot of the ideologies of Bitcoin, which mostly centered around these low hardware requirements. And I generally believe that was the incorrect thing to optimize for if you're trying to actually build applications at scale, because I don't think, going back to kind of my early point around physics as law, if you can move the scaling requirements from the layer 1 to a data availability layer or a Celestia of the world, or you can move the computation from the layer 1 to a layer 2. You can move these things around within different functions of a blockchain, but at the end of the day, they still have to happen. And so I think, Jake, your question in the blockchain industry has really grappled with how much should it cost to run a node in the network so that I can participate and get the properties of the blockchain that I want, which is like verifiability, trustlessness. And I don't know if there's like necessarily a correct answer. The Ethereum people of the world have said, look, this should be on a Raspberry Pi. You should have very low internet requirements so that if you're in different parts of the world, you can still have access to those. The more modern blockchains have said, hey, we've seen over the last couple decades, you can increase the number of transistors on a chip. Once that kind of saturates, you go from 1 core to 2 core to 4 cores to 8, and generally get improvements through parallelism. And then generally, you also, on the flip side, see that internet speeds have increased. Here in Miami, I had 500 megabytes, then it went to a gigabyte. Now I'm at a couple gigabytes. And so the school of thought, I would say, in the more modern architecture design within blockchains that we're a proponent of is, hey, these compute and bandwidth, kind of the core ingredients of blockchains, are generally going to get better over time. And you should write the software that takes advantage of increasing compute, increasing bandwidth, such that you don't have to rewrite the architecture of the technology stack every time, say, core count doubles or the underlying internet bandwidth speed doubles. The software will automatically be able to adjust to that. And I think that's been at the crux of the issue. And then they've also been a little bit more opinionated in saying, hey, maybe $300 or $500 is not the correct amount to optimize for. What if we bump that up to 3,000 or 5,000? Again, I'm not sure, but at the crux of the debate, it's, in my mind, what should the cost of the hardware be so people can participate in the network?
That's such an interesting view. Let me try to give an example, maybe to bring that to life a little bit. So what you said was essentially that developers should build the software with the assumption that it's going to run on basically computer hardware that is fast. And if you don't make that assumption, then you might have to build software that specifically speaks to the limitation of the system that you're running on. But you shouldn't have to do that as an engineer. So maybe like to flesh that out a little bit, it brings my mind back to the early decentralized exchanges and people trying to do market making on those exchanges, right? And what do you do as a market maker? You're following the prices, and then you are updating your buy and sell orders pretty fast to keep up with the price of this market. Now, of course, if you are on a blockchain that has a block time of, Ethereum is set to have 17-second block time, but if you like take a random block, it could take as much as a minute, and you're a market maker, you can't update your order any faster than that. You have to start to think in a different kind of headspace. You're like, I'm in this like slow world, but there's like other centralized exchanges that are trading this really fast, but I can only update my orders once every 17 seconds at best. And what you're saying is if you had this higher throughput situation, then you could just think like a market maker.
Yeah, ultimately, the higher throughput blockchains, I think, enable more expressiveness. Part of that is having the larger blocks and being able to propagate more data. Solana, for example, has 400 millisecond block times. It's, as you pointed out, with the centralized exchanges, you want to get the block times down to as low as like physics allow. The circumference of the Earth with speed of light is 133 milliseconds. So you can get latency down to that point. Maybe you can get 200 millisecond block times, which is definitely not as low as you would be able to get at, for example, a New York Stock Exchange. But I actually do think, this may be like a side tangent, but I generally believe that within the end state of these high throughput blockchains, we can actually build a better financial system that actually enables better price discovery, even though we're suffering from some of these real world latency constraints compared to a New York Stock Exchange where everybody is co-located, has the same fiber optic cable, so no one has an information advantage. There are a lot of things that I think ultimately open up, but moving and subsuming the financial system, I think, is one of the more interesting things.
Seems like it depends on sort of what applications we're looking to unlock, because we've just discussed a bunch of different trade-offs. There's processing time effectively. We didn't talk about costs, but I think most developers are very focused on gas costs because that's their sort of core unit of, eats away their margin, right? If that's what they pay to execute transactions. We've seen probably the two best examples of a fundamental architectural change that produced lower cost that attracted a lot of developers would be like Base, right? By Coinbase subsidizing, I think your first $10,000 of gas is free. Plus, they've got most layer twos have significantly lower gas processing costs. So we've seen, I don't know, like more than 90% of all Ethereum transactions migrate to layer twos. And then Solana, which also produces transactions at much lower fee. So we have cost, we have processing time, we have ease of adoption, like how quickly can I develop and onboard users and compose with other stuff that's there. But I guess the question I'm driving at is, as we add higher throughput and or lower fees, does that unlock a step function change in adoption? If we wanted to rebuild the entire financial system, we probably can't do it like in the next version of the Fire Dancer upgrade of Solana yet, or Sui, or we're several iterations probably away from that. But we do unlock new applications at each step function improvement. Do you guys think about it that way as you invest?
I do think we could actually build a better financial system with maybe a couple iterations post Fire Dancer. Broadly, just view it as, what are better products? Not better crypto products. What are actual better products that are enabled by crypto rails? And that's, I think, going back to like the financial system, I think you can actually have better price discovery on a blockchain than, say, a single sequencer that's located in New York that everybody has the same latency. I really want just people to build products that actually add value to their lives instead of just cool tech for the sake of tech. I think it's taken a while to get there. I think directionally we're on the correct path by enabling higher throughput, by enabling more parallel processing. Both of those, in my mind, are a requirement to actually get to the level of scale that's needed. And then what can application engineers uniquely do within that? But I definitely think, in my point of view, you can build a better financial rails. Again, like, you're going to have some latency trade-offs, but I don't think that necessarily means you have worse price discovery. I think of L2s in my mind as like data compression. You're taking arbitrarily amount of compute, you're batching that, and then posting it on the layer one to synchronize data. But if you push layer twos to their logical extremes, which I kind of like to think of these systems and their extremes and hypothesize about what the results would be, it would be similar to a New York stock exchange, because you would have a single sequencer. Everybody, in theory, if you want an information edge, you would want co-location because you want better latency. I'm not sure if that's a better product. It's open finance, but it's not necessarily better. Where I think these end systems of high throughput architecture ultimately go is, you have today one leader of blockchains, which ultimately act as a monopoly on what gets in the block, the orchestration of the block, the ordering of the block. But the end state of the high throughput ecosystems, and what has starting to emerge as best practice and even starting to be talked about in the Ethereum ecosystem again, is multiple concurrent leaders. In this end state, you can have multiple people propose a transaction and you stitch those transactions together. And why I think this is interesting, because if you have like Amazon West versus Amazon East, like the data centers in the world, you want to submit your transaction, or you want to ping the server that is closest to you, because you're going to have lower latency. And once you have multiple concurrent block producers as leaders, it's similar to being closer to that server. Your transaction inclusion will ultimately have less latency than it would be in the scenario, for example, that you were in Singapore, but there's a single server in New York. You have to propagate your transaction through fiber optics to New York. There's just inherent latency. But when you have multiple multiple proposers, then you can cut down on that latency, what actually is meaningful to the end users. And if you push this a little bit harder, what I think is interesting is, for example, you have an earthquake in Japan. That news information has to be propagated from Japan to New York. And so that trade would then be made at the New York Stock Exchange after that information has propagated through fiber to New York. But in this end state with multiple leaders, what could potentially happen is if there's a leader in New York, that earthquake happens, the traders in Japan know that the earthquake's happening first, they make the trade then and there. And by the time the trade has already happened, that has been propagated to New York and the trade is already made. Now you can have cascading effects of, hey, people are going to keep dumping afterwards because there's a Japan earthquake. But I actually think it's a better way of price discovery, which goes back to my original point in your question, David. I like products, and I'm trying to think about how do blockchains actually enable better products at scale.
Logan, maybe that's a good segue to quickly jump to the fund perspective and ask, because we just talked a lot about the infra tech, but ultimately this is all in the service of products. When you think about it from Frictionless's perspective, how do you think about investing in infra versus maybe like consumer tech, or in any case, products that are going to retail customers?
I generally think the high throughput networks of today are probably going to compound at a more meaningful rate than they had in the past. In a large part, that's because they've been designed to take advantage of increasing throughput and increasing parallelism just through software. The hard part with the previous iterations of blockchains is every time that you wanted to increase the total throughput of the network or increase the computation that the network could have, you had to rewrite the architecture of the underlying tech stack, which I just think caused a lot of bottlenecks, and people invested in different variations to experiment with what would work. And I think high throughput, in my mind, is much closer to the end state than probably most people would care to admit. So we're not as focused on the infrastructure stack. We keep a close eye on the unique things that Sweer is doing or Aptos. How there's some slight nuances in how they do consensus or monad on how they do like parallelism. But generally, they're all in the same vein of increased throughput, increased compute. And so I think it's allowed us to focus a little bit more on what our strike zone should be. And I think the first question that you asked, Jake, was around what are people not focusing on? I think what blockchains are really well suited for are coordination and trading. That trading aspect, I think what is underappreciated today is around order flows and making market makers more profitable over time. We started to peel back the onion of why some of these perp dexes didn't have as much liquidity as we like and why market makers weren't trading on them. And we started going down the rabbit hole of we need more liquidity on chain, and ultimately just started thinking from a market maker perspective. I think today order flows are not as prevalent as they probably will be at scale. But when market makers start competing against each other, especially within the order books, they're going to want to know whether flows are toxic versus non-toxic. And what I mean by that is the toxic flows are like other bots or people that are trying to pick you off in the order book, where the non-toxic flow is just me, I want the best execution possible. And if the market maker knows that you're non-toxic, they'll actually can tighten their spreads because they know that they're not going to get picked off in the order book. You can give the retail person better pricing execution.
We enjoy talking with you, and we appreciate your humility and first principles approach to thinking through the future of blockchains and everything that you're investing in at Frictionless. So thanks for joining us, Logan. That was Frictionless Capital's co-founder, Logan Jastremski. For those of you who tuned in, thank you so much for listening. If you feel passionately that we got it right today or wrong, let's keep the conversation going. Leave us a review and let us know what you thought. If you'd like to follow me on Twitter, my handle is @Pakman, Pakman. And Jake's handle is @JBrook, spelled JBRUKH. Make sure you subscribe where you get your podcast, and we'll be back soon to dig in deeper to ideas that are worth fighting for and find out what people aren't talking about. Thanks for joining us.
Thank you, David, and thanks, Logan. Great to have you.